Welcome everyone to the probability seminar. So this is the last one for this semester. So today we have Siva Athreya from ISI and Rajesh Sundaresan from IIC speaking about the Sero-Survey in Karnataka state, summary design and statistical methodology. So if there are any questions and so on, please feel free to put them in the chat, and if needed, we will interrupt the speakers. Shiva?
Can I start?
Yes.
Okay. Thank you very much for this. This has been a sort of I think, a very enjoyable and a hectic collaboration with many people, spanning many fields, from biologists to healthcare workers to government officials and so on and so forth. There's a nice story about how this all started. Maybe I'll come to it towards the end. The the so Giridhar Babu is the principal investigator, and Rajesh and I sort of were called in to assist on the statistical design part of the survey and the analysis of the data. Before I begin, just one warning. There is too much to say, but too much in the sense that too many little things to say, and they all add up to give a big picture. There's some biology going on, which is very interesting in terms of daily timelines and what a survey says. Uh, there is the probability and the statistics part of it is fairly elementary in some sense, but at the same time, there is a nuance that we will try to explain. Uh, Rajesh is also in the meeting right now. If you have any questions, just please email on chat, and then Rajesh will be able to answer it, and then as we go along. And The preprint of this whole survey should appear very soon in MedArchive. It's not yet come till today, but tomorrow or day after tomorrow it should come. Okay. So there'll be two parts to this talk. The first part I will give. It'll essentially be on the survey design and implementation. Uh, we'll discuss the probability model used and the statistical methodology, and give a quick summary of the findings while I do this. And Rajesh will discuss the nuances, and we'll also discuss our recent work on what's an optimal design for a survey and what's the worst case design for a survey. Okay, so when we began this in early August, the goal was threefold in the survey. One was to estimate past infection, that is, people who have already had the infection of COVID-19. The other unique part of the survey was to also concurrently estimate the current active infection. And this was not done before in any survey, as to the best of our knowledge. And this provided a unique challenge in terms of how to handle the data. Then, of course, once you have these two, the state gets to know what its COVID-19 burden is in terms of the population. So, three goals in the survey. So any survey when you do, it comes with because of limitations of infrastructure and manpower and budget, will come with its own set of bias in terms of how it's designed and conducted. So I will discuss in the beginning the several mitigation factors that we put in place to minimize the bias. So the first was we needed an estimate across the state, so we ensured geographical spread. So all 30 districts were selected in the state, and since Bangalore was sort of a heavily populated area, it was divided into its 8 zones of what's called BBMP, this Bruhat Bangalore Municipality units. So there were 38 units across the state. Then in each unit, the survey chose district hospitals or primary healthcare centers which were across each district. So every district has many such localities in such a way that these locations kind of span the district. Once this was done, you needed counselors, and ICTC counselors have historically been involved in HIV surveys in the past. So they were used to sort of conduct the survey. So you have to go draw blood samples, you have to enter information of the people, you have to go draw nasal swabs and throat swabs and so on. And a key part of the survey, which I think was benefited the state the most, was in terms of budget, was it used the existing public health infrastructure. You didn't have to create something separately for the survey. Whatever was there was used. So I think it was a unique part of the survey as well. Then, as you can see, I just want to sort of show you the geographical spread so that we sort of understand how the survey was done. So you can see a sort of a picture of all the blue dots are where the facilities were. And you can see close to Bangalore, there were many, many more things. I'll just go zoom in a little bit more. So you can see in Bangalore, there's sort of several localities as well, facilities as well, which did the survey. And across Karnataka, you can just look at this map and you can just see we did span an entire geographical sort of region of the state. Of course, some were missed because there were forested areas or there were no healthcare centers. And, some were done more than others, but broadly, the 290 health facilities spanned the state. Then came the next part of the design, which was how do you have a facility now? How do you pick people? So what the protocol demanded was that the population was stratified into three risk groups. Uh, the risk group stratification was based on their risk to the infection, though that was sort of a little confusing at some points in time, as you will see the classification in terms of risk and vulnerability to disease. But, broadly, the design was to assess, to stratify the population in terms of risk to the disease, to getting the disease. So in the low risk, there were people who came for antenatal care, for pregnancy checkups, women mainly, and persons attending the outpatient department and attendees of theirs. And the moderate risk was from the community. So there were bus conductors, auto drivers, there were vendors at virtual market, there were healthcare workers, and many parts of the state have had containment zones at that time. And there were large zones that were there, which were barricaded because of heavy infection in that area. And so individuals from there were sampled. And also congregate settings were sampled in terms of markets, malls, bus stops, and stations. So as to provide to the government information on how prevalence was in these sort of settings. Then the high risk group were elderly and people with pre-existing comorbid conditions. Uh, the last part, the district officials typically had a register in which they maintained this list of elderly and people with comorbid conditions, and they were supposed to be sampled from that list. There was a distinction in the test protocol, that is the RT-PCR, the antigen test, were both done for moderate and high risk groups, and everybody was done the antibody test, within antibody test. And the low risk group, the rapid antigen test was not done. And this is because of the sensitivity to the rat test, which is low, and in that sense, the low risk groups were not given the rat. But the moderate and high were given the rat, the RT-PCR, and the IgG as well. The IgG refers to the antibody blood test. And one small thing, the RT-PCR was done only if the rat showed negative. The rat test came positive, then the RT-PCR was not done to save budget costs because we already know the person has the disease. So that's broadly the protocol. The number 432 was arrived at to attain a certain confidence interval with certain significance and size, which Rajesh might explain in the second half of the talk. I'll try to illustrate that as well as I go along. And the 432 was divided equally across each risk groups, and within each risk group was equally divided across each risk subgroups. Now, that means you have 432 for a district or a unit, and a district has many health facilities. So then what you do is you divide the sample uniformly across all the health facilities as well. Okay, that's how you divide. Suppose there were six health facilities in, let's say, in Dharwad, for example, you would give 12 pregnant women in every health facility, and 12 outpatient departments, and 28 by 6, and so on. And that's how this was sort of carried. So this sort of also gives you an idea of whom we missed in the survey and the breadth we got in the survey. So there's sort of both are available in this sort of slide in terms of how the survey captured the prevalence in the state. Then Within each group, there was very few exclusion criteria. So we only picked people above 18 years. This was due to the fact that typically children are not commissioned to a survey where a blood sample is taken. So that's why they didn't want to get under 18. If you had COVID-19 in the past, you were already tested positive, you're out of the survey. And if you're not able to give informed consent, or you're not able to provide sample for a test, so then I think you're out of the survey as well. Then the sampling procedure was also very straightforward. There was training done. There were across district officials and healthcare workers how to draw blood for antibody test, how to process it to get the serum out, to send it to the lab, how to do the rat test, and on the spot. And the rat comes immediately in about 20 minutes, 25 minutes. So a surveyor would do the rat test and then record the result. Then swabs were sent to the nasopharyngeal swabs were sent to the RT-PCR labs for testing and so on. That's the sampling design broadly. Then the last part, of course, was the data from the survey. This was turned out to be a nightmare in terms of design. So there's collection and compilation. So surveyor entered the data on a specially designed survey app. So there's sort of a specimen referral form ID for every participant called the SRF ID. So that ID was common among the surveyor, the antibody lab that tested the samples and sent to the state government, and the RT-PCR labs which entered into this sort of a centrally mandated protocol in India from ICMR, this medical Indian Council for Medical Research, and so they have a giant portal where all RT-PCR results are entered. So lab results went there, and then they were downloaded by the state government. And then cleaning up took a lot of time in the analysis part to get one line list for everybody, because the SRF ID is 13 digits, and there were several mistakes happening. And also, as you already noticed, that the survey pattern was different, right? So different patterns. So everybody, for example, in the low risk group, you didn't do RAT, and you didn't do RT-PCR in the moderate and high if the RAT was positive. So that had to be accounted for in the analysis. And then this was the first time we had data on both the parameters, the IgG and the active infection. So let me, what's going on? What's coming? Let's see. Yeah. So this is the first crude estimate. So let me just go through this slide and explain to you. So in essence, there were 16,000. Let me make it a little bigger so all of you can see it. There were 16,913 participants who were enrolled. Okay. So of course there were duplications because labs made the health facilities made mistakes. So 320, and then on top of that there were entry errors. So there were 328 duplicate registrations. So we finally got about 16,585 results from antibody labs, out of which 180 were removed because they were unidentifiable into the person. So then we were able to identify IDs for about 16,405, out of which we couldn't map 448 to a district, so they were out. Then we finally got 15,957 samples to work with across the state, which is still a sizable number. Then among these also, 333 were not mapped to a district, and there were name ambiguities as well on the person. So once we had this, 15,624 samples were actually mapped to individuals, health facilities, and district they came from. So from this, the crude numbers are the following. So many tested positive, so many negative, and 18 were inconclusive. And out of the 15,957 from the ICMR portal, we are still awaiting about 1,600 results. We gave up on them. We couldn't get them. So only 13,340 were obtained. And out of which 1,520 were positive and so many negative. And again, from the rat test was done. So many samples were done for rat. So many were positive and so many were negative. And like I mentioned, the protocol, if your rat was positive, so RT-PCR was not done. So that explains the 1,000 numbers here that were not done. So one could think of each vertical column as independent data and estimate prevalences automatically by dividing positive by total number. And one should be a little careful here because I didn't do RT-PCR as rat was positive. So you have to combine these two to get a good prevalence for current infection. I'll come to this in a second, and until the meantime, you can sort of play with this idea how to get the crude estimates. Very nice. So this is the first. I'll explain the model in a second, so to sort of understand what's going on. So the model has to take into account the state of the individual and the test pattern that the individual encountered. So here, the let's say S equal to 1 means the individual has active infection but does not have antibodies. State 2 means that the individual has antibody but no active infection. State 3 is the individual has both antibodies and active infection and active infection. And state 4 is the person doesn't have active infection or antibodies. There are 4 states in the model. And the nominal results, suppose the RAT test was perfect, the RT-PCR was perfect, and the I test was perfect, then it would result in a 110 for S equal to 1. That is, the person has active infection. So both RAT and RT-PCR should give positive. And the IgG should be negative, so it will be 110. Again, if it's perfect, S equal to 2 should give you 001, S equal to 3 should be 111, and so on and so forth. But alas, the tests are not perfect. So that's another thing you have to take into account. Each test has sensitivity and a specificity. So there's a probability of a positive test given the patient has a disease. That's called sensitivity. And the specificity. There's a probability of a negative test given that the patient is well. So these are both things you must take into account for both positive and negative to assess the true infection given the test result. Two state of it. So here I've just given the sensitivity and specificity we assumed. These were provided by a doctor at NIMHANS, who was also an investigator in the team, through various past data of RAT and RT-PCR and antigen results, antibody results that were available uh, to him. And so again, the model needs to take care of several things now. That is the test pattern by the individual. You have to adjust for sensitivity, and you have to adjust for what's called a design effect. Okay, I'm going to try something now. Let's see if I can do that. Come in a second. I'll stop sharing this slide. Very good. Okay, here's a document I'd like to share, and I'll show you a calculation which I want to sort of illustrate the idea. Hopefully my pen will work. This whole thing will start off correctly. Uh, so the idea is now I just want to show you a simple calculation of how one would go about doing this. So what would happen? Let's do an example calculation so it's clear. So here's an example that I will do. Okay. So the first is let's assume the state of the person, of the individual, right? Is, let's say, S is equal to 1. That is, the person has what do you call has active infection but no antibodies. Okay, the person active infection, active, and no antibodies. Then let's say the person was given the test pattern, the test the person was administered, or let's say was given, let's say, the RAT, all 3 tests, the RAT, the RT-PCR, and the IgG test. The person was given all 3. So a person was given, let's say, 111. That's the test pattern the person has. That's the T. Then let's say the outcome of the test, let's call that Y. Let's say the Y was 010. Okay, that's the outcome. Okay. So immediately you see, once you see this, you immediately notice that Y was a false negative because the person was infected, right? Active infection. So Y was a false negative, right? This was a true positive because the person has an infection and has been discovered as positive by the RT-PCR test. Zero means the person has no antibody, so this was a true negative by the antibody test. So these are three things that we observe for every person. We know the test. Okay, we don't know S, but let's say we know S. The test pattern is 111, and 010 is the outcome of the test results from the labs. So then what one have to do is, if you want to calculate the probability of getting outcome Y for the individual given the test pattern S and the state S and the test pattern T. This is what you have to calculate. So how does one do this? This let me denote it by, in the notation I've called it Q O Y S T in the slides, which I should go back to in a second. And that gave you, this was 1 minus, so rat was false negative, right? So rat was false negative. So you do 1 minus sensitivity of rat. That's for the rat negative. Then the next is your true positive for the RT-PCR. So you have to multiply it by the specificity of RT-PCR.
Shiva, there is a question in the chat.
Rajesh might answer, or
Okay, fine.
yeah, Rajesh will answer.
Shiva, that will be sensitivity.
Which one?
The one that you just wrote as specificity.
Oh, sorry, yes, true negative, right? True positive, true positive. So true positive is sensitivity. Very good, thank you. Sensitivity of that, sensitivity of RT-PCR, because it's positive. Thank you. And the last is specificity of the IgG. This would be the calculation one has to do to get the probability of observing Y when the state is S and the test pattern is T. So this is a crucial sort of idea one has to sort of implement in sort of estimating the probabilities when you have all three results. That is the rat result, the RT-PCR result, and the IgG result. Very good. This is one thing I wanted to emphasize. I will just go back to this to the slides. Let me try the gymnastics again. Let's see if it works. Okay. So this is where we are now. We have these test patterns for every individual, and these are the states of every individual. And depending on what test you got, you would have various scores like 001 or 01NA. And the sensitivity and specificity. So now I'll summarize quickly what I'll do. Rajesh also will go over this again. So I will just sort of go a little quickly on this because I want to spend some time on the findings. So T is the test pattern. Y is the test result that you got. S is the state that's hidden. You don't know what the hidden state is. So again, you can estimate the likelihood of getting Y given S and T in terms of the sensitivity and specificity matrix that I had. And you get exactly this formula that you can write it down. It's not that hard. And suppose P1, P2, P3, P4 were the probabilities of the individual being in one of the four states. Then the probability of observing Y given test pattern T for individual N is given by the sum over all possible states, P of YS given T, and that's just P of S QY given S. And once we have this, you're on your way, because then you can write a likelihood function. Just you go to let's say you go to a particular strata in the population. Let's say district was your basic unit. For each district, you write the likelihood function down as P of T, Pt comma D, T comma Y. You look at the number of people in the district. You multiply you think of them as independent samples. You multiply the whole thing, and then you luck out that the map is concave. Of course, you can't explicitly solve it. You have to do numerically in R using a package called constraint optim, and you can use a numerical gradient descent procedure to arrive at the maximum likelihood. So P hat will be P1 hat, P2 hat, P3 hat, and P4 hat. So remember, S equal to 1 was, like I discussed before, this active infection and no IgG, S equal to 2 or something else, and 3 or something else, and 4 something else. So then to get the antibody prevalence, it's just P2 hat plus P3 hat. The active prevalence is P1 hat plus P3 hat. And total prevalence is sum of the first three. That is P1 hat plus P2 hat plus P3 hat. That's that. So this is what you're after. So you do the analysis, you run the program in the MLE, and then run the MLE program in R, and out pops a number, and these are the numbers that you have for every district. And at the state level, then what you can do is you can also do confidence interval for the estimates that you have. This is also very standard. You can do a Fisher information matrix outside of the model. Use a design effect of 3. If I have time in the end, I'll come and explain design effect. But as of now, I think I'm a little short of time, so I'll skip that part. That design effect is to account for correlations between individuals in the sample. So if it's IID, then design effect is just 1. There's no problem. If it's not IID, some correlation, you have to add a design effect. And why the number 3? If I have time in the end, I'll explain. The rest of it is very standard. You have to be, all you have to do is make sure the test pattern is different across participants. So you have to use what we would interpret as some sort of hybrid observation or a Fisher information matrix, with just the invariance of the matrix will provide the estimate for the covariance. And with that, you can obtain the confidence interval. The last thing is for the state, you have to weight it. If you know you have estimates for each district, because you've done 432 samples in each unit, you have 38 units. From that, you have to get an estimate for the state. What you do is you take each estimate in each unit and multiply it by the fraction of Karnataka population that lives in that district, and that will give you your P hat. And assuming independence across districts, you have a covariance matrix with W squared and then times covariance P hat. So that's broadly the model part of the talk. So last 20 minutes or so, or 18 minutes, I will try and discuss the findings of the survey. Okay, the first one is, okay, what's happened statewide? So how do you estimate the numbers statewide? So I gave you a numbers in the beginning, which gave you the crude estimates. I don't know if you kept, the numbers have gone far behind 3-4 slides ago, but that gave you an idea. You had 2565 positive antibody tests. Total samples were 15939. So the crude estimate for antibody would be 16.1%. That's just crude, without assuming any correlation or the fact that you've done all 3 tests, RT-PCR, RAT, and antibody. If you had only IgG, you would have said, okay, 16.1% was my crude estimate. And so on and so forth for the active, and the total prevalence was just the sum of the two. You just get the answer and move on. The adjusted prevalence, you'd have to adjust for sensitivity of the test, like I told you, because each has the sensitivity and specificity. If you adjust for it, it'll come down a little bit to 15.4, 12.2, and 26.1. Of course, now I have to adjust it by the weights for each unit separately. So I do this estimate across each district D. I multiply it by the weight, and then I get the weighted adjusted estimate. So it's 16.4, 12.7, and 27.3, and the bands are quite small. The intervals are quite small. It's not that big. It's 15.1 to 17.7. It's quite a reasonable estimate. Now you have another interesting observation that so biologically is very interesting to see that see if you add 16.4, 12.7, that is these two guys, and then that gives you sum of people antibody and active, and you subtract the estimate that you got for the total prevalence, that's 27.3, that gives you 1.8. That means 1.8% of people in the population are carrying both antibodies and current infection. Rajesh will give you a biological explanation for that in his talk, why this happens. Though we also know that there's variation across districts, which I'll show in a second, which is why this 1.8 estimate should be considered with a pinch of salt. So now you can draw you can do it for every unit. So I've shown you the graph in every unit. So the black dots represents the IgG prevalence at each district, and the blue band represents the confidence interval. So now you can see the Karnataka one is red in the middle right here, in this middle right here. That gives you a sort of a small interval at 16.2, and everybody else is quite large. The intervals are quite large because the sample size is only 432, whereas Karnataka was at 15,000 odd. But the key finding in this is that there's variation across districts or units. Or, for example, if you go all the way to the top, a zone in Bangalore, which is a west zone, has 35% prevalence, whereas someone like Bagalkot or Gadag has only 6.3 and 4.1. So it's variation across units. Also, you would think, okay, districts close together might have similar variation. That doesn't seem to be the case as well. For example, there's the zone called Mahadevpura, which is sort of a large zone in Bangalore with densities fairly small compared to the other zones in Bangalore. It has a very low prevalence of 7, whereas the west, south, and east have quite a large amount of prevalence. So they have seen a surge in cases. And this is as of September 3rd. Okay, not currently, we are about 2.5 months away. No, yeah, more than 2.5 months away now. So this is 2.5 months before what the data is telling. Then you can also do a similar thing for the active infection and the COVID-19 prevalence. You can draw bands of this following form. I wrote acute because the biological term for active is acute, so I didn't think on the graph, but they call it acute infection. And again, you see variations across district. The ordering is different. It's not the same as the one in the IG that I showed before. So this leads to sort of, if you look at districts as a whole, you clearly see many things. So the first thing that you see is A, the state is observing pandemic in different stages across different units of the state. It's not uniform across the state. That's number one. The second number we are not able to explain is that the data shows a high percentage of active infections. So this is something that's disputed biologically, that why are you observing such high numbers actively? For example, like Ballari, active numbers are about 35%. That's kind of high. And why is that high? Some places quite high. So it's not Ballari may be an outlier, you can forget about it, but there are other districts that are also quite high. So it's something that biologically one needs to understand why this is happening. Maybe the state was going through a peak at that time, and we captured the survey. The survey captured the peak in this form. That's one explanation one has to observe. Then there are these other classical epidemiology metrics that I would like to sort of go over a little bit. So until now, everybody's happy to talk about percentages a lot, 16.7 and this and that. Then suddenly you want to say, okay, fine, now I want to estimate the total infection in the state. I multiply my percentages with the population in that place. If my survey was well designed, this should give me a true understanding of estimated infection. That's point number one. Then you have been reporting cases on a daily basis through your testing policy. People come into hospitals, or you do randomized testing in the community, or how the state does it. Then the survey gives you an estimate. You reported some number of cases. Now you can understand how many cases you have missed. And that's called the case to infection ratio, which I'll explain in a second. Then, of course, now you've also been reporting deaths, the number that have been occurred. You know there's so much past infection from the IgG prevalence that you obtained in the survey. That's an estimate. Sorry, excuse me. Now you can use that to understand what the infection fatality rate is. So now you know fatalities up to 2nd September have been reported across every district. You sum them up, and you can get the infection fatality rate for the state. So the IFR and the CIR are the two key concepts to remember: case to infection ratio and infection fatality rate. So CIR will tell you how many cases you have missed. IFR will tell you how many deaths you have missed. So that's kind of an idea. So now let's go to the Karnataka estimated numbers. So the state estimated reported 48,494 4,84,954 cases up to 16 September. If you multiply it by the total prevalence percentage that we got of 27.3 times 7 crore population in the state, you estimate that there's about 2 crores that are already either currently infected or have been infected earlier. So you can clearly see there's sort of a huge mismatch between the second column and the first column. If you do the calculation from before, the CIR comes out to be 1:40. That means for every 40 cases in the state, you're detecting one of them. We are told that this number is sort of comparable uh, across states in India. It's not that off. And world over, we are told that 1:20 or 1:10 is sort of the ideal numbers to aim for. The fatality rate, the IFR is at 0.05%. This is comparable with Asian data, but not comparable with data that's obtained in, let's say, Italy or Spain, where you're at 5% or 6%, not 0.05%. So that means either it could be underreporting of deaths, or you could not be catching deaths as COVID deaths, and so on and so forth. These are up for questions to understand, but these compare with Asian data. And you also have an estimate for how much the state is missing in terms of daily active infections. Now I plot the case to infection ratio and the infection fatality rate across districts. Now this gives you how each unit is performing in terms of the CIR will tell you, the case to infection ratio will tell you how every unit is catching cases in the unit. So example, if you look at Vijayapura, it has a very high CIR. That means it's missing a lot of cases. Whereas if you go down all the way, a couple of the Bangalore zones, the BBMP and the Mahadevpura, which had even low prevalence, has low CIR. That means it's doing well. It's catching cases that are coming out in the market or in the unit. IFR high means it could be many things, that either you're reporting deaths better than other units, or there could be a lack of awareness in the population in terms of getting medical help. So there are more deaths. Low IFR means you could be misreporting deaths, and your reporting should be examined in some sense. So the survey gave very useful information to the state to sort of act on in terms of these criteria. So instead of going through the numbers like this line by line, I'll show you a quadrant picture to give you an idea of how to understand this idea. Okay. So Karnataka's IgG prevalence, that is past infection prevalence, was 16.7%. And the IFR was at 0.05. That's Karnataka. So let's take Karnataka as a standard and compare everybody else with that weighted average. So every unit will be high or low depending on how it compares to Karnataka numbers. So that's what I call high IgG and low IFR. That means its IgG numbers were higher than Karnataka and IFR numbers were lower than Karnataka. If this was the case, then you know that high IgG means that your district has already had surge in cases in the past. Low IFR most likely indicates either a good healthcare system or you are underreporting COVID-19 deaths. And similarly, high IgG, high IFR means you had a surge and you perhaps reported deaths better. And low IgG, low IFR means your surge is going to happen soon. It's not yet happened as of September second week. And low IFR means that either there are fewer deaths or they're underreported. And low and high on this side, on the bottom quadrant, means that the district is yet to see a surge, but there's high proportion of deaths due to either due to COVID-19, the early phase of the outbreak itself. So something has to be examined in terms of how the unit is medical, clinical management is ongoing, and one has to assess that properly. So I just draw this graph here. I plot on the x-axis the percentage prevalence. On the y-axis, I have plotted the infection fatality rate. So I get the four quadrants as I gave in the previous slide. That is, this quadrant is high IFR, high IFR and low IgG. This quadrant is high IgG and low IFR, and so on and so forth. The four quadrants, and Karnataka is right here in the middle. So as you can see, if you look at the press, for example, everybody would say that Bangalore is doing pretty badly, BBB South is doing badly, and West is doing badly. A lot of cases happening, but uh, but in this graph you get a good picture. See, they had high prevalence, but they also reported deaths better. They had high IFR and high IgG, and they perhaps are doing better than other units in the in the state. Whereas someone like who has low IFR and high IgG, like these people like Vijaypura or Belgaum or Ballari, need to be looked at a little better because somehow they may be underreporting deaths. Then you can combine the CIR also with this IgG and IFR. So if you had high prevalence in the past, that's high IgG, you missed a lot of cases, that means high CIR, and you reported deaths a little less than they should have reported. That means you have gone through a surge, you have missed air circulation, and you have underreported deaths. So you should really get your act together and sort of see what is going on if you're in this particular uh, set of three. If you're in the high IgG, you're in the low CIR and high IFR, that means you're doing well. That means you've had a lot high prevalence in the past. Your low CIR means you've caught most of the cases. That means your testing system is working well. And high IFR means you perhaps are reporting death in a reliable manner. So one should look at, these are the three key parameters one should look at to decide how a unit is performing. So typically one in the state, at least in the ICMR reports that you see, they look at how many cases are coming, how cases are rising, and they decide to allocate resources in terms of testing resources, and or even classify how a unit is doing, or how municipality is doing. But I think the survey tells us a different story, that places with high cases but low CIR are perhaps doing better. So in the next graph, I point out this thing. So I plotted the CIR on the y-axis. On the x-axis, I've plotted the IFR. And the green blobs indicate the size of the IgG, that is the size of past prevalence. So the bigger the dot means you have higher prevalence. The smaller the dot means you have higher IgG prevalence. That means you've not, if you have a small green dot means you have not had cases in the past. Your surge is yet to come. So you can see, like for example, BMP RR Nagar or Bomanahalli or or even the west, east, and zones, which are sort of in the news for doing so not so well, are perhaps doing better. They have low case infection ratio, they have moderate IFR, and they have high IgG. That means they've handled the surge in the past in a certain way. So they could be used in terms of the state to practice with other units. Whereas if you look on the first quadrant, you're doing quite badly because you have high CIR, you have low IFR, and if you have a bigger green blob, the surge has come and gone, and you have missed a lot. So you must sort of see what is happening. Right? And if you have a small green dot, that means your surge has not happened. So you could learn from these units in this bottom quadrant to try and understand your performance. So it's sort of a very revealing, a survey gives you a very revealing idea about the state of the pandemic. There's variations, there are units that are performing better than others, there's relative behavior that one can observe. and one can go and see techniques done in each unit to sort of understand. I'm almost done with my sort of talk. Uh, I'll conclude with a couple of broad remarks. So the survey also has estimates across risk groups, which I didn't mention and discuss: age, gender, subcategories. So the government can know which congregate settings to open, not open, depending on the prevalence. The survey also found out what the estimated rat sensitivity was. Among asymptomatics, it was as low as 46%. Among symptomatics, it went to as high as 70% or 67%. It also gave we also did a regression to understand the prediction of past and current infection from symptoms and pre-existing comorbidities. Manju, can I take 30 more seconds and finish off this talk? I'm at the 45-minute mark.
Yes, you can take several minutes.
Okay. So prediction of past and current infection from symptoms, and this is a very interesting study we could do. I mean, I'll show you the results in the next slide. We were also able to furnish district-wide reports. So each district got a report saying where they were with regard to Karnataka's average and what changes they had to make in terms of clinical management, death autopsy, testing policy. And one of the most rewarding parts of the survey was that we were able to give the state how to tweak its testing policy across units, or how to rearrange it. And it was very professionally done, and we really enjoyed that aspect. And Karnataka is going to maintain its testing rate till the end of December at a high rate, even though the number of cases are going down in terms of at least the video game of daily timelines. We also found one interesting fact, which I've repeated. Sorry about that. We found if you have bouts of diarrhea, and you're sort of it's an indicator you've had past infection, either noticed or unnoticed. And there's an in contact with with a COVID positive also gave a strong was a strong predictor for past infection. So I'll conclude by showing that graph. This is a graph of predictors that we sort of. So diarrhea was one for past infection, that's red. Nausea, headache were predictors for active infection, and then the presence of viral RNA. And again, time. So the inception also was a key factor in terms of identifying past infections. Of course, the classical symptoms, fever, chills, fatigue, head, muscle ache, sore throat, were all strong predictors for active infection as well. That the survey showed. The survey form had a questionnaire where the patient filled out whether they had these symptoms in the past or they're having this currently, and that's how we got this. There's this nice seminar tomorrow on COVID Gun. There's a seminar group by Giridhar Babu, who is the principal investigator for this entire survey. So it's run by ICTS, I think. I encourage people to handle it. Attend it if you can. It's at 6:30 p.m. tomorrow evening on Thursday. Apparently, you have to register. I'm not sure about this, but you can take a link at this. Okay, I've taken 2 minutes more than I got. Thank you very much. I'll just end with a slide where we have on this website, Rajesh and I and others, we are trying to build up an ensemble model of predictions for various units across Karnataka. I'll close with that, and I'll allow Rajesh to start part 2. Thank you very much.
Okay, thank you. Are there any questions to Shiva?
There are actually quite a few questions on the chat. Maybe the participants who posed those questions could ask, and maybe Shiva could respond, just to keep it a little more interactive.
Yes, anyone in the chat whose question is not entirely answered, please unmute yourself and ask.
Yeah, Abhay here. Though Rajesh answered my question, what Dipayan also mentioned, that the survey is planned in such a manner that you are missing a lot of a large group of the population, those who are not in those three groups. So it may not be the results of the survey survey may not directly be extrapolated to the entire population of the state.
That's a comment and a observation, I think. But I don't know if Rajesh mentioned it in the chat. I have not checked. But it's about prevalence. So you have to buy into the fact that the prevalence is the same across outside outside these risk groups. That's why the extrapolation is valid. And also it's we have not. It is true we have missed quite a few people, but we have covered a fair large amount of people in that sense. That's something that one has to sort of. But you're right. So there is in any survey you will miss people. You will capture people, uh, but uh, but the biologically we have been told that the prevalence obtained in terms of average across these three risk groups can be multiplied across the rest of the population. That's something that either you sort of.
Yeah, Shiva, just a follow up. Yeah, I agree with you about prevalence, but about the CIR and so on, that is where it might be a problem.
Yeah, estimated infections is always an issue, but it is an indicator in terms of relative grading across the districts.
Okay.
The two numbers you can of course you can argue whether it's correct, whether the EI number I said 2 crores infected is the correct one. That may be also you can argue, but the relative numbers tell you a story.
Okay, thanks.
I don't know if Rajesh has another comment. I'm not so sure.
So there is a question by Gautam Menon. Maybe you can ask Gautam.
No, that just had to deal with the question of symptoms and the relation of that past infection. So if they were self-reported, often there could be, people don't remember symptoms very well, especially if there is sort of 1 or 2 months past. So just a question about that. How much do you think how much do clinicians trust this correlation that you found?
The symptoms is something that was self-reported. That's correct, and there could be the errors that you mentioned. We recently were forwarded an article which I tried to post in the slide account. Apparently, there is one study that says COVID-19 stays in the gut for about 90 days post-infection. Apparently, the virus. So diarrhea apparently is sort of a believable symptom in some sense. This is the only feedback I got about the symptoms as such. Others I do not know. Rajesh may have add more.
I would like to add one more point in the self-reporting request. The request was to report symptoms that they saw in the last 1 month and nothing more. So,
Okay.
but I think despite that, your point is well taken. So people may not remember exactly when they encountered the symptoms, and there could have been some misreporting.
Thanks.
If I can just add to this is Dipan. If I can just add to what Abhay was saying, I think there is a fundamental problem that you will miss people who are very reluctant to go out and so on, and they may be related to like their economic conditions, right? So high income people could afford to sort of stay home and work from home, etc. So I don't think there's any solution to that. It's just something that you have to just give as a disclaimer.
That's accurate, I think. I don't. Rajesh, you think that's accurate, right?
Yeah, I have one addition to make, which actually heightens Deepayan's point that the survey was centered around sentinel sites, which are actually government hospitals. And the users of this are particularly those that may not be as well-to-do as those that go to private hospitals and so on. So I think your point is a very valid point.
Okay. Are there any other questions?